Hey everyone, how you guys are doing in this lockdown period? I hope everybody is doing fine. And today the main aim of our talk is to talk about body comp or body composition assessment. Now, before we dive into the main presentation, I just want you to have an overview of our presentation. This time I want you to do a bit of an exercise at the beginning. I will walk you through this exercise and then we will talk about why we need to know about body comp assessment. We will then move on to discuss in detail what body composition is, what are different body composition models, and then we will discuss three specific techniques: the BMI, the waist hip ratio, and the skin fold thickness assessment, what we normally do live in our labs. And then we will look at some of the other techniques which we are not using but we still can use to assess body comp. And then we will revise some of the main points. And then at the end, I'll talk about some of the evaluation questions which are due at the end of this presentation. So let's get started. Now, if you look at your handout, you will have this document which says buzzwords. Now, the idea is that I want you to have a look at these words, try to refresh your memory, and if you can recall something about those words, whatever you know, whatever you recall, whatever you have read them anywhere, just write it in the first column of this no wonder learn chart. So the idea is that whatever things you already know, you want to write in the first column, and then the things which you want to know or you are curious to know, you should write them in the second column. This exercise may take 3 to 5 minutes. You can pause my video, do this exercise, and then start the presentation. I am going to continue with my presentation and I hope that you guys will pause it and then after doing this exercise, then listen to the main presentation, leaving the last column which you should fill at the end. And whatever I'm saying right now, it is there in the instructions. So the biggest question, as we have been asking ourselves again and again before every presentation, that why as kin students you should know about body comp assessment. And there are a number of reasons. I have just jotted down a few. You can think of it, but if you are thinking about these reasons, you are doing a really great job. So the first one is that as adults, once we tend to age, we are gaining about a couple of pounds weight or fat mass to be specific every year, and we are losing approximately half a pound lean body mass every year. So it means that we are getting fat, we are getting more and more, we are accumulating more fat, and we are losing lean mass. This is dangerous, and this has really bad implication on our health, physical fitness, and performance. If you see, we have a lot of health risk. We have increased risk of cardiovascular, cerebrovascular, all kind of obesity related diseases. There is always a problem of weight gain and weight loss. For athletes, you want to maximize your performance if you know your body comp, and we want to fit into the societal norms by getting lean and thin and posting our photographs on different social media sites. So, as far as I'm concerned, this should be the order of priority for all of us. But unfortunately, this is the order of priority why people are hitting gyms, why people are doing body comp assessments, and why they are again and again trying to, you know, um, track their weights while they are doing exercise. So this is unfortunate, but ideally we should have the green line going. Now, after knowing this background, now is the right time to know what body composition is. And you can see the definition is really self-explanatory. It says that it body composition refers to the components or the pieces or the parts that makes up our body. And the biggest thing I want to emphasize right at the beginning before we dive deep into different stuff related to body comp assessments that we can only estimate it. We cannot exactly measure things. We are not going inside the body measuring things. We are just estimating, which means that there is always some error percentage while measuring. Okay, now this is the big definition of American Nutrition Association, which says that net lifetime accumulation of different nutrients and other substrates which we tend to get from the environment, and they remains or get retained in the body. So this is a complex definition. If you forget this, just remember that body comp made is defined as the components which make up our body. If we want to divide this whole stuff of body comp into two parts, it has to be the fat mass and the fat free mass. You can see the fat mass depicted in violet, the fat free mass in red in this diagram, and we have used other colors here. Now let's concentrate on the fat mass. Fat mass is divided again into two components: the essential fat, which our body needs for its normal physiological functions, and the non-essential component. If you see the essential fat, we have the cell membrane, the lipid bilayer model, which we have been studying since high school. We have the vitamins, all the fat-soluble vitamins, which include with vitamin D, vitamin E, vitamin K, and vitamin A, all kind of hormones. For example, we have the steroid hormones, we have the sex hormones. All these hormones have lipid as their essential component, and then we have the Schwann cells of the nervous system. The non-essential fat is the stored fat, which is the big problem, and we tend to take more and more food which accumulates as fat, and that all is storage fat. So if we go back to our previous slide, we have talked about the fat mass. Now what constitutes fat-free mass? And you can see in this diagram, the fat-free mass is about the bone, the protein, and the water. So these are the three big components of the fat-free mass. So keeping this fat-free mass into perspective, let's move on to reliability versus validity. These are some very interesting concepts, and I want to use a diagram to reiterate my point once we see their definitions. So if you see on your screen, the classic definition says that a reliable measurement is one which produces reproducible results. So what does that exactly mean? That means that if you continue doing it once, twice, or many times, you are likely to get the same result. So if a measurement is giving same results with multiple trials, that measurement is reliable. And valid means, if you look at the second definition, it means that it should measure what it actually owes to measure, or what actually it should measure, which comes me to go to this diagram and see that if you look at these dots, you can see them scattered. Every time you plot a dot, it's at a different place, so it's not reliable, and they should be there in the central circle, but they are not there, which means that this is neither reliable nor valid. If you see the second one, this is reliable because every time you're hitting these big circles, you are getting them nearly at the same place. But these should be there at the center because that's where they meant to be, but it's not the case here. So this is reliable, but this is definitely not valid. If you see the third diagram, here you go. We are getting all our dots inside the central circle where we intend them to be, so it's valid, and they are not scattered here and there, so they are reliable every time you get a dot. So this is the classic definition of reliable and valid. Okay, now it's time to look at some of the body comp models depending upon the compartmentalization. So if you see the compartmental classification, there are two component models which we have already discussed: the fat versus non-fat, which you can see on this diagram on the left side. I have a couple of examples for you which says underwater weighing and skin fold thickness. I'll discuss skin fold thickness in a lot of detail because this is one of the techniques which we do in our lab. And the underwater weighing, I'll just touch on it once we discuss the miscellaneous techniques. If you look at the more common model, these are the multiple compartmental models. So apart from fat and fat-free mass, we divide fat-free mass into other components. So it can be 3, 4, 5, 6. More the number of compartments, the more accurate the measurements will be. So in general, you can see that multiple compartment models are way more accurate than the two compartment models. And I have highlighted that 4C, which means that the 4 compartment model is the most common one which we use. And DEXA is a big example. I'll again come on to it once we discuss the miscellaneous body comp assessment techniques. Right. Now, before we start discussing each of those techniques, I want you to understand the level at which we are assessing body composition. So in general, you can assess body composition at a molecular level. If you are talking about the proteins, the carbohydrates, and the fats, you can determine at the cellular level if you are combining them in the form of cells or in the form of tissues. You can also determine them in the form of skeletal muscles, maybe smooth muscle, the cardiac muscle, or the bone, or we can determine them as a whole in our body. And I want to emphasize this again and again that in our lab, whatever techniques we are using in this practical, we are assessing them at the whole body level. Although we have techniques which assess them at other levels, but we are not performing them in our lab. So I just want you to be very sure that you are assessing these techniques to assess body comp at the whole body level. Right, so the first one, the simplest one, the BMI. You might heard of it, you might have taken it a lot of times, but I just want to summarize some of the key information which you should be aware about BMI. So as the definition says that it is an indicator of body fat and it is based on two big measurements, the person's weight and the person's height. And how do we precisely determine it? By using this famous formula where you put the weight in kilograms in the numerator and then divide it by the height of the square of height in meters. So you just get the weight of the person and divide it with the square of height and you will get the BMI. So that looks really, really simple. But we know that despite it's simple, it is associated with a risk of a lot of diseases. I have enumerated 3, which is the diabetes, the hypertension, and hypercholesterolemia. But there are other cardiovascular and cerebrovascular diseases which are linked with increased BMI. And if you want to know more about it, you have to know the different ranges of BMI to know more about obesity and how obesity is related to cardiovascular risk. Now, because this measurement is simple, you can do it easily, so it has its own pitfalls. And the first one which I want you to think about it is that it won't separate low lean body mass from fat. So this is a big issue. I want to give you an example. You can find a person whose BMI is, let's say, 30. That person has high BMI. From the BMI classification, he is, in the obesity, he's overweight or maybe touching the obesity. But he has a lot of lean body mass and he has very less fat mass, so he is really fit. But as per the BMI classification, he is obese. So this one won't segregate fat mass from the lean body mass, and this is one of the caveats of BMI. Now, the other one is that how fat is distributed. We don't know that where fat is exactly located on the body. And these are the 2 points which lands us into our second part of the discussion, which is the abdominal girth and the obesity. So we have to think beyond BMI. And the abdominal girth, which we measure, is the distribution of fat in the upper abdomen, which has all those serious consequences which I have already talked about in context of diabetes, hypertension, obesity, and hypercholesterolemia. What I exactly mean to say, just look at these two pictures. You can see here that men tend to have more tendency to gather fat on their abdomens. Females have more tendency to gather fat at the abdomen and also in the gluteal region or the hip area. So this type of obesity, which is more common in males, is known as the android obesity. The one which is more common in females, this kind of distribution is known as the gynecoid kind of obesity or gynoid obesity. But we want to know more about it. And in order to know more, we have to evaluate it. In an ideal world, we want to do a CT scan, a computerized tomography, or an MRI, a magnetic resonance images to get these measurements really, really fast and extremely accurate. But this is really expensive and it's not possible to do it on a mass scale. And we know the world is not ideal, so we have to bear with one of the things which we do in our lab, which is the waist to hip ratio or the WH ratio. So we measure abdominal girth by waist to hip ratio, and how we are going to do that, let's have a look. We take the circumference of the waist and just divide it with the circumference of the hip. And the exact technique I can just show you from this figure. You can see that this figure shows that males and females have just slightly different areas to measure the waist circumference and the hip circumference. But I just want to tell you what your lab manual says. It says that you want to measure the waist circumference at the narrowest area here, and you want to measure the waist circumference at the widest part of the body. So you want to stand on the side of the patient, measure the narrowest area around the umbilicus or maybe above the umbilicus or the navel, and you'll get the waist circumference. Again, stand on the side of the patient and measure the widest part around the gluteal or the hip region, and you'll get the hip circumference. Just divide them and you'll get the waist hip ratio. It sounds simple, but this is being used in a lot of researches, in a lot of studies, and is again a good indicator of a lot of diseases. And this is the standard measurements given in most of the textbooks. A waist hip ratio of above 0.9 for men and above 0.8 for women are related to a really high risk in a lot of diseases. And the diseases again are the diabetes, hypertension, cardiovascular diseases, obesity, and hypercholesterolemia. All right, so we are done with the BMI, where we measure the weight and the height. We are done with the waist hip ratio, where we measure the waist circumference and the hip circumference. And now we are about to talk about the measurement of skin fold thickness. Now, before we discuss how we are going to measure the skin fold thickness, I want you to have a look at the principle. The principle is really, really the key to this measurement. We are measuring the subcutaneous fat, the fat which is there beneath the skin. And we are assuming, we are making an assumption that that subcutaneous fat which this guy is measuring here is proportional to the total body fat. So we are just measuring fat which is beneath the skin and then put it in an equation to get the whole body fat estimate for the whole body. And this instrument, in ideal scenario, we should have been using to get the skin fold thickness in our lab, but the instrument is almost similar what you are seeing in this picture. It measures the thickness of the fold of a skin which is underlying or beneath the fat. Now, I want to talk quickly about the technique with the help of this diagram, although you have specific video links at the end of the lecture where you can see that in males and females respectively, there are 7 specific sites where you're going to do the skin fold thickness. But The technique essentially is the same, and I'm going to take an example of this subscapular skin fold thickness. Now, the idea is that you're going to hold the skin with your thumb and forefinger of the non-dominant hand and just shake it to make sure that you are only holding the fat, not the muscle which is beneath it. And then with your dominant hand, you can just hold this caliper. You can use this handle to just open it, and then this caliper should be perpendicular to the skin fold which you are holding it with your other hand, and you try to clutch this caliper approximately 1 to 2 centimeters below where you are holding it. Then once you release it and those prongs goes inside the skin, then wait only for 1 to 2 seconds so that it allows the reading to be there at the right spot, and then you immediately note down the reading and don't get it off immediately. Just unlock it and take it off. So if I want to revise the steps again, hold the skin, whatever is the site, shake it so that you're only holding the fat, hold the caliper perpendicular, couple of 1 to 2 centimeters below the skin fold, wait for 1 to 2 seconds to get the reading, unlock it, and then take it off. Now, whatever readings you're going to get, just put them into the equations and get the whole percentage body fat as per the principle which we have already talked, because skin fold thickness varied with age, gender, and race. Now, because as we have already talked that because it's an assumption, and I've already talked at the beginning of the lecture that we can only estimate body fat with this percentage. So with this particular technique, there are 3.5% chances of error, and we have to consider that error, although there are equations which can be used to minimize this error as well. Okay, there you have all the video links which you can just click and see all the 7 sites which I explained really nicely for both males and females. And then if it would have been an ideal world, as I've already said, you should be able to do it. But as of now, just watch the videos, solve the questions, and I think you'll be good. Now, before we end this whole discussion, we have concentrated on 3 techniques: the BMI, the waist hip ratio, and the skin fold thickness. But I want you to know that there are some other methods which are also implied in assessing the body composition. So these techniques constitute: the first one is the underwater weighing. This is based on Archimedes' principle of buoyant force, and we are measuring the amount of water displaced once a person moves beneath the water. So the principle says that whatever water is displayed is equal to the body weight. The other one is the BIA, or the bioelectrical impedance analysis, which is really used pretty commonly in most of the gyms and all the exercise and fitness centers. So the idea here is that they pass very low intensity electrical current to the body, and the impedance to the electric current is measured by voltage, and depending upon those numbers, what voltage we are getting, we put them into equations which indirectly estimates the body fat and the lean fat mass. Now, this one, this picture is taken from our department. This is the big DEXA, or the dual X-ray energy absorptiometry. So it measures bone density by passing very low intensity X-rays through the body, and the amount of X-rays which are absorbed in the body will be put into an equation, and we can again get the measurements, the bone density, and the other body comp measurements. The last one is the air displacement plethysmography. So this principle is pretty much similar to the underwater weighing. The only difference here is that it's the volume of air which is displaced if the person is put in instead of water, and the principle is the same. The volume of air displaced is proportional to the body weight. This is, by the way, known as pod, and I think the picture is taken from Dr. Tinsley's lab. Okay, so we have come to to the end of our presentation, and I want you to highlight whatever I've been talking for the last 15 to 20 minutes. We have talked about the importance that why we need to know about the body composition. We looked into the body composition in a lot of detail using different definitions and different divisions of body composition. We look at different body composition models depending upon the compartment, the 2 compartment, 3 compartment, the 4 compartment. Then we specifically looks and did discuss in detail about the 3 techniques of body mass index or the BMI, the waist hip ratio, and the skin fold thickness assessment technique. And at the end, we have talked about some of the other techniques which can be used to assess the body composition. Now, I think after this big discussion, you should go through these exercises. So the first one is about the evaluation questions, which is of 15 points. Whatever you have learned so far, most of the information you will get from the lecture. So I want you to complete those buzzwords and no wonder learn activity at the beginning before you attempt these questions. And once you go through the lecture, solve that activity, I think it would be pretty simple to solve all these questions. And this one is a lab activity, which is of 5 points. So the idea is that I have put in all the measurements of weight, height, waist circumference, and hip circumference. You need to average all of them and put them in the formula for the BMI and the waist hip ratio. So the idea is that you should know how to use the information in practice and know the theory behind them by answering these questions. So that is the end of the presentation. If it would have been a live class, I really encourage all of you to ask me a lot of questions, but you can still do it. Just feel free to email me, and I'm more than happy to answer whatever questions, confusions, or queries you have. I hope you have a good time watching this lecture, and I hope to see you soon in the next video. Thanks for listening.